Good evening. Tonight's lesson is on combining like terms with multiplication. Once again, there are a few rules or a few properties that I'd like to review. The first is the commutative property of multiplication, which, just like the commutative property of addition, states that you can change the order of a multiplication problem and still get the same answer. For example, 2 times 3 is 6, and 3 times 2 is also 6. The answer stays the same. The second property is the associative property of multiplication, which states that you can keep the order of the numbers, but change the grouping. Parentheses starts first, 2 times 3 is 6. Bring down our 4, and 6 times 4 is 24. On the right side, if you notice, we change the grouping of the problem, and we have 2 times 4, which is 8. Bring down the 3. 3 times 8 is 24. So the answer to the multiplication problem does not change. In example 1, we have 3 times 2x. And if you recall from last night's video, you'll remember that, that 3 times 2x really means 2x plus 2x plus 2x. Ooh. Sorry, guys, not doing good today. Okay, and when we add our like terms, we just add the coefficients. 2 plus 2 is 4. 4 plus 2 is 6. So we have 6 x's. And if you take a look back here, we multiply the 3 times the 2, we also get 6. Let's take a look at example number 2. We have 4y times 5. Go ahead and pause the video, try it out, and come on back. Okay, hopefully you paused the video. What I would like to do is I want to rewrite it, and I'm going to put in the multiplication sign here, or the multiplication operation there. Okay, and I noticed that 4 and 5 are not together, so I'm going to use the commutative property to switch the order, because remember, 4y is the same as 4 times y. So when we rewrite it, we have 4 times 5 times y. With the commutative property, we are not changing the answer. We're just making it easier for us to solve. Now I take a look. 4 times 5, I know is 20, times y. So our final answer is 20y. Okay. Example number 3, we have 3 times 2x plus 4y times 5. If we take a look at the first part, we notice that we have 3 times 2 times x. And I'm actually going to rewrite that to make it a little easier. The second term, we have 4 times y times 5. Now, luckily, the first term has the 3 and the 2 sitting next to each other, so we do not need to use the commutative property. 3 times 2 is 6 times x, so we have 6 x's. Now, if I take a look over on the right, I see that once again, my 4 and my 5 are not next to each other. So I'm going to use the commutative property to change the order. Okay. Bring down our 6x plus, and I know that 4 times 5 is 20, 20y. Now, if I take a look at 6x plus 20y, I know that they are not like terms, so I cannot combine them. We are done with our answer. This is in simplest form. If we take a look at example number 4, please pause the video, try it out, and come on back. Okay. If I take a look, I notice that I have 3 times 3 times x plus 4 times 2 times x. Once again, if I look at the first term, luckily the two numbers are together, and I do not actually have to use the commutative property. 3 times 3 is 9 times x. On my right, 4 times 2 is 8. Bring down the x. And if I take a look, I notice that I have 9x plus 4x. I hope that you realize that 9x and 8x are like terms, so we can combine those. We're going to add the coefficients. 9 times 8 gives us 17 x's, and we have simplified. Okay, we move on to example number 5. We have 2 times 2y plus 3 times 2x. Remember, we have 2 times 2 times y plus 3 times 2 times x. Okay, once again, we're lucky that we have the numbers next to each other. We do not need to use the commutative property. 2 times 2 is 4 times y. We bring down the y. Plus 3 times 2 is 6. We have 6 x's. 4y and 6x are not like terms, so we cannot combine them. We have simplified our problem as much as we can for today. Tonight, what I would like you to do is I'd like you to answer the question number 1. Alexander says that 6x plus 4y is equivalent to 3 times 3x plus 2 times 2x. Is he correct? Why or why not? Please answer this question, have it ready for tomorrow, and we will discuss it first thing. Have a good night.